Recording, Ree. Thank you, Ree. And we'll wait a moment before we get into the presentation itself. Let some of our participants make their way over here. And I'm just checking chat functionality working. And Q&A is all ready to roll. We're at a minute after. Let's give it one more minute, Scott, and
okay.
And then I'll go to the presentation. Starting to see folks come in, so everyone's grabbing their coffee quick here at whatever time zone they're in. Yes, or water jug. I've got both here as well. So hot and cold, hot and cold. Mouse all fired up, ready to go. All right, we're 2 minutes after 1 p.m. Eastern time, so why don't we begin? Welcome everyone to the second of our summer webinar series related to the IPS products, Industrial Path Solutions. I'm Carl Bangert. I'll be hosting today with my colleague here from Sandalwood Engineering. We'll give a quick introduction to what we're planning to show you here and a bit about who we are. Sandalwood Engineering, who is graciously hosting this platform, is a company that I think you all are familiar with, 130 strong, with offices throughout North America, in Canada, the US, and Mexico, providing engineering services support for systems engineering, systems integration, injury prevention, and ergonomics, and a range of services that fits very well with the Flex Structures IPS product line. Flex Structures were based in Germany, Kaiserslautern, Germany. Over 50 people now, in the process of moving to new office space over there. Myself, I represent Flex Structures here in North America, together with we've got, my apologies, I sent the wrong, I had the wrong slide active. My colleague here from Sandalwood is, let's unhide this one. This is the one that was supposed to go with Scott Butts, Digital and Systems Engineering. Say hello, Scott.
Hello, everybody. Thanks for joining.
Apologize for that.
No worries.
The other slide was less. You'll edit that out. You're right.
Of course.
Together with me, I'm Carl Bangert, General Manager of Flex Structures North America. So the focus of our webinar series is to provide insights into the various IPS tools used to help the virtual validation process, both in product design and assembly and manufacturing. Trying to help you all realize the goal to go to zero physical prototypes, work in the virtual space in a zero fault forward environment, as we've been helping folks in major automotive companies and other industries throughout the world, being able to get validated product designs years before start of production. So that's where we want to take you. The flagship product is IPS cable simulation, helping to get to the bottom of the process of laying out, designing wire harnesses, cables, routing cables and hoses in vehicle and mobility systems. What we found as our work in cable simulation has proceeded is that there are other highly elastic components that need to be examined as well. And that makes up part of the IPS product line. So these tools will work together with cable simulation, things like assembly path planner, and digital human modeling, all in the space. And today, as an add-on module to IPS cable simulation, we're going to present Bellows and Grommets. Here, highly elastic components that are often in the same space, powertrain compartments, engine systems for IC and electric vehicles. So with that, I'll turn the baton over to Scott Butts to explain a bit about what we're presenting in and what we offer with IPS Bellows and Grommets.
Well, thank you, Carl. I'll start sharing my screen here. We have a little example to share for you today. So we can see here on my screen, we've got a little air intake system that we'll be looking at. So over on the left, we have an airbox assembly here. On the right, we have our intake that will bolt to the engine here. And in between, we've got this bellows right here. So all we need to do to be able to turn this into a flexible component is if we first, I'll hide all the other geometry so we can see everything clearly. And now, if I take our bellow here, I'll go to the flexible menu and use the bellow finder tool. That will open up a window here, which gives us step by step exactly what we need to do to make our flexible component. And you can see the first step here is finding the center line. So I'll click that. And it'll ask us to pick a start cap and an end cap. And really all we're telling it here is where the beginning and end of this bellows are. So I'll place a start cap here. And I'll just drag it in front of the opening here. And now I can pick the end cap. And we'll do the same thing over here. And now if I just hit generate center line, we can optionally add an offset, but we don't need to today. If I hit generate center line, the program will find an approximation of the center line for this bellow. It usually only takes a few seconds here, and now we can see already we've come up with our center line. And if we rotate it around, it's exactly in the center of the bellows there, so I'm happy with that. I'll hit continue. So now, next step, we can see number 2 is available now, specify mesh resolution. And as you might expect, we're specifying the mesh resolution on the surface here for all the simulations. There is the auto option here as well, and I would say in most cases that will work just fine. And if we hit the auto button, again, it just takes a few seconds to get through the calculation to come up with its own mesh right here. And we can see just like that. If I zoom in, we have all our triangles here. One other tool that's in here that's optional is step 3. We have this adaptive meshing tool. And we can see here, we've got a pretty fine mesh across the whole part here. But if I hit the adaptive meshing button, and I'll tell it to generate a mesh again, it'll leave that old mesh we generated behind, and it's going to create a new one based on the complexity of the part here. So when that comes up here, we can see the wider, flatter, less complex areas of the part here have larger triangles and less detail. But where we get into more complex shapes in the geometry here, we have a finer mesh that'll capture that detail for us. So that's really handy if you have a large part that you're trying to cut down on calculation times. But you can also specify your resolution manually. And for today's example, I'll just put in 100 by 20 here. And we can see, once again, anytime you generate a new mesh, it will replace the old one, and it just takes a few seconds. And we can see there's the mesh I manually created. Now there's just one thing left we have to do before we make our flexible component here, and that's adding the boundary conditions. And the boundary conditions are just going to be our fixation points at the end of the bellows here. And if you remember, there are a couple clamps on either end here. So we'll try to target those areas. We have a couple different options for selecting where those go. One would be add by constraint geometry, but the way we have this model set up, we don't have anything constrained yet. So I'll show you add a constrained range right here. That will bring up another menu. And we can either type in a value that will be anywhere along the length of the center line, or we can use the drag bars. And we can specify the start and end of the range of vertices in our mesh here that we want to be part of that boundary condition. So with that, I'll bring these over to this end, about where the clamp was. And I'll bring these over too. So now we have our start and our end. And if I hit OK, we can see still highlighted there. These are the vertices I've chosen as our boundary condition. And we have one other option for picking our vertices for our boundary condition. So to set the one for the other end here, I'll select the Add by Selection tool. And now I can just hold Shift and do a lasso select. And we can see that'll highlight all the points that I've just selected. That looks okay to me. That lines up with the clamp we had there. So I'll hit OK again. And I'll say OK in the boundary conditions window. So now we've got our center line, we've got our mesh, and we've got our boundary conditions. And that's all it needs to create the flexible component. So now we can hit Create Bellows. And that will bring up yet another window. And this is the shell editor. It's going to create what it calls a shell from this geometry and this data. And in this window is where we'd put in our material properties for this part. For today, I'll just leave the default values in, which are about that of a semi-hard plastic. And I'll check contact handling enabled. We'll take a look at that again later. And I'll also check the box to make it interactive. And what that will do for us is later on when we're moving things around, it'll allow us to see the bellow actually moving in the motion and everything. So I'll hit OK. And I'll close the bellow finder window. And you can see we have the bellow right here, but this is actually still just the geometry that was imported originally. So I'll just hide that. And now we get this here. And this is that shell I was talking about. So this is the actual flexible component right here. And what that shell means is it's taken the geometry from our original imported part here. And it's created a middle surface, which is going to be roughly halfway between the outside face of the bellows here and the inside face. So if we hide that geometry again, here's our middle face. And this is what's going to drive all the calculations for the bellows and flexible components. One thing we can do if we just right click on the shell, is we have this visualization option. And you can see right here, like I said, we have this middle surface right here. We have another couple options too. We have middle surface with thickness, which that will add back in the thickness of the plastic that's used in the bellow there. But it's still based on that middle surface geometry. And if we change it to the original geometry visualization, it will look just like our original geometry. And one thing to note, That middle surface is still what's driving the calculations, but I like to put the visualization for the bellow itself back on, just to make sure we can see everything later on. Another thing we can do with the bellows here is we have a visualization color coding menu here, and we can put a color map on this. And we can do a few different things: contact pressure, equivalent strain, von Mises stress, and displacement. I'll choose von Mises stress today. And we can see that puts a color map on the part here. And obviously blue, like most color maps, will be the lowest stress and red will be the highest stress. If we want to see what those values are right now, we can right click again and in visualization color coding, we can bring up the color map, and that will tell us right now the red here, our maximum value is really only 0.008 megapascals. So that's why we have red there, even though we're in kind of a resting state. It's pretty low stress here. And usually that will auto scale. You could uncheck that and add in a manual red value if you'd like to, or a low value as well. I'll just leave it on the auto scale. And one more thing we can do is we looked at those values in the color map there. But if we wanted to have an actual measurement taken for our maximum von Mises stress right here, we have this option to create a value measure. And you can see we have a few options for that too: maximum displacement, maximum von Mises stress, contact force, and nominal length. I'll use the von Mises stress. And if I click that, you can see down here in the bottom right, now I've got this stress value, and this is the maximum value in the part here. I'll just change the color of that real quick to make that easier to see. And now, if I grab one end of the bellows here, we can see we have this shell in the model tree, and then these unions are going to be our boundary conditions that we set. So if I take one of those and I start to move it around a bit, we can see in the viewing window, it'll update in real time wherever I'm dragging it. The color map updates as well. And you can also see down on the bottom right, that maximum stress value is going to update as well, all in real time. So I'll just put that back where we started for now. And we also have imported into this simulation here, we've got a motion, and that motion can be taken from your native CAD program. Right here, we've just got a motion for simulating engine shake. So if I bring in our other components here again, and I'll play through the motion here first. We can see our engine components here, everything that'll be bolted to the engine, those move around, but our bellows don't yet, because we still need to attach them. And all we need to do for that is we need to connect our boundary condition to our geometry that will move with the engine here. So to do that, I'll click this button right here, create connection frame. And we can see I've now got a connection frame. All I need to do to connect the boundary condition to that, I'll just select it and drag onto the connection frame. And then likewise, I've got to connect this connection frame to this geometry. So I'll just select the connection frame and drag it onto our geometry here. So now, if I play through the motion again, we can see now our bellows are connected to these components over here. And as we run through the motion, again, we can see the color map updating. We can see our value measure updating as well. Now that we've got our motion and everything attached here, something we can do with that motion is we have our value measure down here, and we can see what this value is as it plays through the motion. But if you wanted to capture that, you can analyze a motion, which will bring up our menu here. We can look at any value measures that we have created already. We've only created this one. And if I hit OK, what this will do, the analyze function, is that's going to create a plot for us, and it's going to plot that von Mises stress throughout the motion. And once we have that plot up, we can take a look at minimum maximum values and things like that. And what's nice about this is you can see that happened really fast. Any other simulation softwares I've used, everything takes a while, and you run the simulation, maybe it takes a couple hours, and then you realize, oh no, I made a mistake at the beginning, and now it'll take another couple hours to run again. You can see here, we've set all this up and we've created this plot, and it's really only taken us a few minutes. So in the viewing window here, we can see we've got time on the x-axis and our stress on the y-axis here. So we can see throughout the motion how the stress behaves. And in here, we can also edit the graph a bit. We can change some colors. We can look at minimum maximum values as well. Like if I wanted to find the maximum stress value anywhere in the motion here, I just look for the global maxima and hit find. And that will drop a dotted line right here on the graph at the maximum value. And you can see if I hover over it, there's a question mark next to my cursor. So if I click, that will tell us exactly what time that this maximum stress value happened at, and it will tell you exactly what the value is too. Another handy thing, if I move this down out of the way a little bit, you can see we had that go to button right here. And if I hit that, it will snap the motion directly to that point. So we can see exactly the position everything's in when we hit that maximum stress value. And if you wanted to export this graph here, all you got to do is hit the Save Plot button. And we can save it in a handful of file types. So now I've exited the plot. We can see this the motion jump back to the beginning here. And another thing we can do with this flexible here is we can, and the motion it's attached to, is we can create a motion volume. And what we can do with that, while that's generating here, this will just take a few seconds. What that's going to do for us, it's going to create a piece of geometry that's an envelope that is everywhere that this bellow will travel through as it moves through the motion. So it will occupy all the space that the bellows would occupy. And again, the software, I really like how fast it is. On my computer, I'm just running this on a Microsoft Surface, and you can see everything's still going pretty quick. This isn't any sort of fancy high-powered machine or anything like that. And in just a few seconds here, we'll get our motion volume. And when we have that, that'll show us all the space it'll occupy. And once that shows up here, I'll make it transparent so we can see that.
While we're waiting for that, Scott, could is it possible to take a collision with other geometry into account as well?
Yes, it is, and we'll go over that in just a second here, actually.
Okay.
But here, I'll hide the other components here again. We can see it came up with this piece of geometry here that over on this end, where the bellows isn't moving very much, we can see it's just about the same shape. But as we get over here where the motion occurs, it gets a little more bulbous. And like I said, it shows everywhere that the bellows will pass through. So just as a demonstration, I'll make this transparent here. And if I play the motion again, we can see the bellows move around, and we can see that that's exactly the space it will pass through. Another useful thing we can do with that, I'll hide our actual shell here so we can see it. We can, I'll make it opaque again. We can export this geometry. So you could send this back to your native CAD system and put it into your models there with a handful of different file formats. And you can check for clearances with other components and things like that. So I'll hide this again and bring back our shell. And like Carl brought up, if you remember, when we created this shell, we enabled contact handling. So if I bring in just a primitive shape here, this is just a solid cylinder I've created, nothing special. But since we enabled contact handling earlier, we now have the option to set up contact handling. And that will open this menu where it will just ask us with the bellows here, what other geometry we want to check for collision with. So I'll add this cylinder here. And now, if I take this cylinder and I move it into the bellows here, we can see the bellows will move and react to that. It will displace those, and we can move it around. We can see down the bottom right, our stress value is updating. Obviously, the color map is updating as well. And that's very useful, again, for checking clearances with other surrounding components. And that's about all I wanted to show you with the tool today, but I'll also mention, besides firewall grommets and like we just showed here, our intake bellows, some examples of other components we can use this tool with can be grommets that will pass through door hinges for wiring harnesses. We have CV boots that we've used this with, steering rack boots, and it can also be used for hard plastic fittings like this one. And with that, I believe we'll open it up to questions.
Another question that had come in is you can have multiple instances, or can you have multiple instances of bellows and grommets within one model?
Yes, you can.
Mm-hmm.
Yeah, you could create multiple bellows within one model. We just did one here, but if you had multiple, it'd just be the same process.
Great. That was the only other question that we'd gotten at this time. I would mention also to folks that are listening that additional features that are under development include being able to apply a pressure and interior pressure to the bellow. So if you've got a net positive or negative pressure, that would be taken into account. There's work being done to include stiffening rings as well, and then also to handle complex wire and cable grommet interactions, different types of geometry there. So this is an add-on module that it's been getting a lot of attention recently. I know we have some folks here in North America that have brought the module on and found good use for it. Again, it's not intended to replace perhaps some very detailed FE analysis that might be being done in the durability and fatigue space. But however, to get a fast and accurate representation of a flexible structure very early in the design cycle, you've got great opportunity here with Bellows and Grommets, and leveraging the work that you're likely doing in IPS cable simulation as well. So appreciate you walking us through this, Scott. And with that, I think we're at the half-hour mark. Thank you all for your time, and be on the lookout for a video that you can share with your colleagues who may not have been able to get on at this time. Thanks again, and have a great rest of your day. Thanks, Scott.